4.3 trig ratios. We're just starting this today. All right. In grade 10, I think most people in grade 11 use X, Y's, and R's, but for those of them that don't, in grade 10, we use SOHCAHTOA. So we're going to go over that. So sine theta equals opposite over hypotenuse. Cos theta equals adjacent over hypotenuse. And tan theta equals opposite over adjacent. So why we use X, Y's, and R's instead of opposite, adjacent, and hypotenuse is solely due to the fact that every angle we look at is going to start out of 0, 0 and terminate outwards. So if I looked at 30 degrees, it's an interior angle, correct? This value here would be my what? If I was using opposite, adjacent, or hypotenuse. And this one would be my, and this one would be my hypotenuse. We agree? Because all of our angles, though, are embedded on the Cartesian plane, rotating around 0, 0, we're not looking at this angle here, are we, ever? No. So if we did look at that angle, this would be opposite and that would be adjacent. They would flop, correct? But we never look at that one. We only ever look at our interior angles because we rotate around the 0, 0. We agree? So adjacent could be known as X because it's the X value. We agree? And it's not going to flop because we never look at this angle up here, which would turn that to opposite. Opposite would be replaced with the Y value, and hypotenuse is replaced with the radius. Because this could technically be a circle rotating around. Do you agree? Okay. So we're not going to use opposite, adjacent, and hypotenuse anymore. We're going to use X, Y's, and R's because X, Y's, and R's are going to make way more sense for us because we're embedded ourselves onto a Cartesian plane. Not just a random triangle floating on your page. Okay? Shh. So sine theta then is going to actually be opposite over hypotenuse, so it's going to be Y over R. And there's silly ways to remember it, and I'll give you one of them. So the way you can remember it is sign your resume. I came up with none of these, just so you know. This is the only one that kind of seems normal. The other two are not. I have 4 people in here who are in my grade 11 class, so they know this awesome acronym. I was going to say stupid, but they're just super awesome. Just wait. All right. Cos theta equals adjacent, which is X, over hypotenuse, which is R. And you can use Cook extra price. Yes, that is extra with an X. You think it can't get much worse. Oh, but it does. Okay, tan theta equals opposite, which is Y, over adjacent, which is X. And you can remember that by tan your X box. Because why not? Now, these 3 trig ratios you've seen your whole, well, since grade 10. You've seen sine, cos, and tan. And originally when you saw sine, cos, and tan, you don't remember this, but you were overwhelmed and you were like, what the heck is this? Sine, cos, and tan. Just like you were overwhelmed when I told you there's a radian measure that's the same as the degree measure. Okay? Because it's new, so you freak out. So I'm forewarning you, there are 3 more trig ratios. These trig ratios are called the primary trig ratios. Then there's the secondary reciprocal trig ratios. So these 3 ratios actually have best friends, just so you know. They're not alone. They have best friends. So don't freak out. Just write them down, and eventually they'll become part of you, just like these are. When you don't see these, you don't freak out. So sine has a bestie. Its bestie is cosecant. CSC. Spelled cosecant. Okay? Sine has a bestie, cosecant. It's its reciprocal trig identity. So what does that mean? Reciprocal means flips, correct? So sine is y over r, sine theta. So cosecant theta is r over y. For those of you who write things like this, sine equals y over r, what you have actually written to me is sin equals y over r. Have you found the answer to sin? Because that's what you're telling me. Sinning is just y over r. That's what because this is absolutely not sine. This is the word sin, and it equals y over r. That is the crazy, thank you. We now know how we sin. We just y over r, and we're good. And then we know how we cos. We just cos x over r, and then we tan with y over x. So there's some cover over between sinning and tanning. Didn't know that either. It's quite impressive. That makes some sense. You need to have a theta beside here. And then people are like, you're just being a stickler. No, that's where the angle goes. If you don't have that, it's bad. This one's cosine. This is cosecant. Why is it called cosecant? You're questioning why that's called cosecant, but not questioning why the other ones are called sine, cosine, and tangent? Yeah, someone decided. Whatever, you can do what you want. Riddle me this. Okay, so if you forget who are besties, shh. If you forget who are besties, your formula sheet will tell you. So look, sine and cos, secant, those are best friends. Secant and cos are best friends. The C goes with the S goes with the C, and then cotangent and tangent at least have the same word in them. So it makes sense. See, told you don't be overwhelmed. It's just brand new. Everything's brand new to you. Okay, so best friends with cos is secant. And instead of it being x over r, it's r over x because it's its reciprocal identity. And then we have cotan. Cot. And it's the reciprocal trig identity to tan, so it's x over y. All right. So example 1. Given the following point, on the terminal arm of some rotational angle find the exact value of all 6 trig ratios. So, the point we're going to use is -2 and -6. What's great about -2 and -6? We have x and we have y. And in our trig ratios, what are our options of letters? X, y, and r. We're just missing r. What do we know about a point from way back when we were little? It's a point on a graph. You can draw it. So let's do that. Okay. So -2, 1, 2, 3, 4, 5, 6. Here's my point. Now it says, given the following point on the terminal arm, so that's where the arm ends, where does the terminal arm start? 0, 0. And where do we always draw towards? The x-axis or the y? The x-axis. That's where we go for reference angles. That's where we go for drawings. Right? And where are we rotating about anyways? The center, correct? So if I drew it here, it wouldn't be as easy to find. And the reason why we always draw towards the x is these will lead us to reference angles, which we've talked about numerous times. So let's label what we know on this triangle. We know that our x is a value of -2. We know that our y has a value of -6. How do you suppose we're going to solve for the radius? Yes? I know where you're going with that. So it would be x squared plus y squared equals r squared. It's Pythagorean theorem. Okay, so we are going to get -2 squared plus -6 squared equals r squared. We're going to get 4 plus 36 equals r squared. We're going to get 40 equals r squared. And then we're going to take the square root. And what are we going to remember? When we take the square root of something? Yes, plus or minus. The catch is that the radius is a distance. The radius will always be positive. So if you forgot, you'd luck out if it was the radius. But if it was x or y, it matters. Because x can be positive or negative, right? So can y. So now we have r equals root 40. That's great. It says exact value. So for those of you who are putting root 40 into your calculator and getting a decimal, is that an exact value? No, because it doesn't stop. It doesn't terminate. I can't write the actual answer. And the moment I round, it's no longer exact. It's approximate. So this is still a good answer, but it's not going to be in reduced form. So square root of 40 breaks down into what? What perfect square? 4 and 10. So you can bring the 4 out, and it's a 2. So you get 2 root 10. That's one way that people do it. Other people do it as breaking down prime factors. So whichever way you do it and get it correct, I do not care. So what they do is they break it down to all the prime factors, which is 2 times 2 times 2 times 5. And then they do like a 2 for 1 deal. So I can take out 2 that are the same for 1. And then they get 2 root 10. Do I care which way you do it? No. Do I care that your answer is correct? Yes. Okay. Would I off to the side show my work if this was a written response? Absolutely. If you're doing anything in your head, the person who's marking it has no idea what you've done, right? And say you mess up, they can't even give you part marks, correct? Remember, no one can even see who you are. When they're marking your test, they don't know who you are. It's a test just sitting in front of them, okay? That's when I mark your written response, I mark your written response with flipped over pages. I don't know who you are when I'm marking it. I mark your multiple choice and numeric response first, and then I flip over to the back of the test, and then I mark the written without me seeing it. After I mark it, if it's a really good question or a really bad mark, I sometimes flip slowly to the front to see whose face it is. And I'm just like, good. If it's bad and if it's good, I'm like, woohoo. But, you know, I may do that. But I only do that after I mark because I don't want to be partial. And they aren't partial because they have no idea who you are. Even if your name was on it, they don't know who you are. Okay. So 2 root 10. So let's do our trig ratios then. We know we have x is equal to -2. We know we have y is equal to -6. And we know we have r is equal to 2 root 10. Then we do our trig ratios. So what's our first trig ratio? We can do sine. Sine what? Your resume. So sine theta is going to be equal to y, which is -6, over r, which is 2 root 10. What's my issue? From grade 10, or grade 11, sorry. Yeah. Yeah. Can't have a radical in the denominator, so we have to rationalize the denominator. So we've went through grade 10 and 11 just to even get to this spot. Grade 10 in reducing the radical and Pythagorean theorem. We've used grade 11 in order to rationalize this, right? So what people do is they try really hard often in grade 12 and they're like, I don't know why my marks aren't coming out great. Well, there's so much 10 and 11 in here that unless your basis for 10 and 11 is super strong, you're learning again, okay? And also, sometimes you've done grade 11 first semester and you're doing grade 12 second semester. That's a long time of trying to remember something. And then not to mention 10, which was how long ago, right? So sometimes you're just remembering. And then it comes back quick. Okay. So we have root 10 in the denominator. We can multiply by root 10. What happens when we multiply 2 roots together that are the same number? They cancel. Why does the root cancel? It technically doesn't cancel, but... You write root 10 over 10 because it's 1, that's how we multiply top and bottom, but no. What do you do when you multiply radicals? Radicals, awesome. So say you have square root a, c root a times d root a. What do you do when you multiply radicals from last year? Multiply first times first, so c times d, so cd. And then radicand times radicand, so a times a, so a squared. Then what happens? These cancel. So cd would times a, right? So root 10 times root 10, oops, times root 10 is root 100, which is 10. That's why they cancel and go away. Yeah? Okay. So then we're going to get equal to -6 root 10 over 2 times 10. And I show all my steps, because if I make an oopsie, the further I go, the better I am off. -6 root 10 over 20. And then if my coefficients, I can take something out of them, I do. I can take a 2 out of both. So this becomes a 10, and this becomes a -3. So my answer is -3 root 10 over 10. So sine theta is equal to -3 root 10 over 10. Ultimately, that's what that trig ratio is. Yes? What about cos theta? Cook? Extra rice. Yep, Ben? What's up? Because you're dividing the top and the bottom by the same number. So over here, we multiply the top and the bottom by root 10. So as long as we do the top, it's okay as long as we do to the bottom as well, or the bottom as long as we do to the top. So same thing with division. When you're crossing these off, what you're actually doing, you've negative 6 root 10 over 20. What I'm actually doing is I'm dividing the top by 2, and I'm dividing the bottom by 2. So as long as I do the same operation to the top and the bottom, it can go away. So that's all I'm doing when I'm canceling these off. I'm dividing them both by 2. You just have to know that you have to be able to do it to every term in the entire thing. So say when we do binomial, or say when we do quadratic formula, and you have negative 2 plus or minus 6 root 3 over 5. That's why we can't cancel it, because we can't take the same number out of all 3 terms. Like this is a term. Terms are connected by plus or minus signs. Sometimes a plus and minus sign. Here and here, right? So I can't take anything out of all 3 of these, the 2, the 6, and the 5. So I can't take it out, because you have to be able to take it out of the top and the bottom. Okay. Cook extra rice. So we're going to get cos theta equals x, which is negative 2, over r, which is 2 root 10. You could reduce right here. You can reduce at the end. I'm going to reduce at the end. Multiply by root 10 and root 10. So I'm going to get negative 2 root 10 over 2 times 10. Which is negative 2 root 10 over 20. Take a 2 out, and I'm left with negative 1 over 2. Nope, that's not true. Negative 1 over 10. So it's negative root 10 over 10. We're actually done the hardest trig ratios. Why? Because x and y are simple numbers, and these are the only 2 trig ratios where r is in the denominator. And r is my one with the radical. As long as my r is in the numerator, I don't have to rationalize it. Yeah. If I said to solve for all 6, yeah. What would they do? Probably ask for one of them. What one would they probably ask for? The one you have to rationalize. My betting guess. Okay. All right. Tan. Tan theta is tan your xbox. So tan theta equals negative 6 over negative 2, which is 3. Then we do the friends. So sine is cosecant, so CSC theta. And sine is sine your resume, so this is going to be resume your. They flip, because they're reciprocal trig identities. So cosecant theta equals 2 root 10 over negative 6. That's why this one's easier, right? The root 10 is not on the denominator because r is in the top. We cancel a 2 off of both of these. I'm left with a 1 and a negative 3. So it's going to be root 10 over negative 3. Then cos's best friend is secant. Secant theta. If cos is cook extra rice, this is rice extra. So secant theta equals 2 root 10 over negative 2. 2 out of 2 is 1. 2 out of negative 2 is negative 1. So it's root 10 over negative 1. Although that is correct, that's probably not the answer they'll give. What do you think they're going to give? Negative root 10. And way back when you were younger, they would give you stuff like this when you started learning negatives. Negative 3/4, let's say, is equal to negative 3/4, the negative outside, right? Is also equal to what? Three over negative 4. As long as there's only one negative in the fraction, it's correct. right? So if this wasn't a 1, if this was a 2 or a 3 or a 4, say we had root 10 over negative 3 like this, they could keep it like that, or how else could they answer it? Negative root 10 over 3, and it would be the same answer, wouldn't it? So you have to keep in mind, they can move their negative around, right? I'm just going to go like this, just so that people don't think it has anything to do with these, and then like, where did she get that number from? She didn't get it from anywhere. She made it up. That's fine. And then our last one is cotan. Cotan theta. So is best used with tan. So tan is tan your x box. So this is x box your. So cotan theta equals negative 2 over negative 6. What? Okay. You guys remember cast rule from back in the day? You two just whatted? And I know you know because I taught you. So cast starts in the bottom right and goes counterclockwise. So we have C, A, S, T. So instead of cast, some people say this, start in the top right and they go, all students take calculus, but that's not completely true at all. So, but neither is tanning your Xbox. I think it's fried if that happens. Maybe try it out. I don't know. You know, options. But what do those letters mean? Yeah. That's where they're positive. So all of them are positive here. Sine is positive here, tan is positive here, cos is positive here. But also their best friends are positive there. So cosecant is positive here. Cotan is also positive here. And secant is also positive here because their besties are positive there. Right? What quadrant are we in? Where was that point in? 3. What's positive in quadrant 3? Tans and cotan. Tan and cotan. There's no sign there. That's where they're positive. Where the letters are is where it's positive. So tan and cotan are positive there. Yes? Okay. So when we go to look at our trig ratios, the only ones that should be positive are cotans and tans. Sine is negative. Cos is negative. Tan is positive. Cosecant is negative. Secant is negative. Cotan is positive. Okay? So I'm going to give you some homework to work on.